You may hear many explanations of what the intelligent edge is. Quite simply, it's the placing of resources at the location of best return. Whether that is an immersive experience in the metaverse that requires low latency, or a factory relying on machine-to-machine communications and AI for factory automation. It's the intelligent edge that really enables this. The edge for me represents the gap in the connectivity and processing resources, including memory and storage, required to deliver captivating experiences in real time to hyper-connected devices and users. Now, not all requirements for latency and responsiveness, realism, interactivity, and more can be really delivered on a device or through a hyperscale cloud half a continent away. That's regardless of how much bandwidth we have to our local access point. Physics ultimately wins. And it takes time for data to go from the user through a network to a system that can process it, and then come back again. And for a growing number of use cases, that model just doesn't work. The user experience breaks down. The world requires an intelligent edge as a complement to basic connectivity to provide seamless experiences for all. What determines workload placement? Well, I mentioned geographically induced latency a moment ago, but there are other factors, including data transport costs, security and sovereignty, availability and local support for services, and data value ephemerality. We are already seeing a tremendous investment in building infrastructure for the edge. Hyperscale cloud vendors building more regional data centers in order to get closer to the customer and address other concerns such as governance, for example. There's been a growing shift in distribution of where data resides and is processed. We've shared how devices were getting smarter and capable of capturing or generating more data thanks to new functionality. This is shown pretty clearly in the robust CAGR for data growth in endpoint devices, roughly double the growth rate of the traditional core cloud. Edge computing allows more opportunities for analysis of data and closing the loop on automation, and taking actions based on data to be much more responsive to business needs. For example, sensor data from a local machine may indicate that it'll be shut down due to overheating or performance degradation over time. The same sensor data from its machine can be used at a building or campus level and in aggregate be correlated to determine risks of larger scale system failures and even optimal maintenance scheduling. Regionally, the system and productivity data from these machines may be helpful in shifting overall productivity or influencing energy procurement policy.